All right, let's go ahead and continue with creating a timing diagram. So in Quartus, a timing diagram is referred to as a vector waveform file, which has a .vwf extension. Throughout the course, the timing diagram will be referred to simply as a VWF. This file will be used to validate the functionality of the project. So let's get started. To create a new VWF, choose File, New, or again, perform the Control+N. And in the pop-up window called New, select University Program VWF, then press OK, or just double-click on University Program VWF. And let's go ahead and show you what that looks like. So you see my mouse, hopefully. All right, go ahead and go to New. You see the pop-up window? Go ahead and scroll all the way down to where it says Verification Debugging Files here. And down under this, you're going to see the University Program VWF. Go ahead and hit OK, or you can double-click that, but just hit OK. You're going to get this window. Right? So this is the Simulation Waveform Editor window. It's going to pop up. The signals associated with the pins of the BDF, they're going to be added. So to add these signals, right-click the mouse in the region highlighted by the orange star. Right? And so that means right here. And then a window called Insert Node. Let me make this a little bit larger. Is that better? I hope. Okay, and make this just a little bit bigger so you can see. And then we don't need to see that little thing. There we go. All right, let's start all over. Where were we at? So in the simulation waveform editor, right, we are here. It says the signals associated with the pins of the BDF will be added. To add these signals, right-click the mouse in the region highlighted by the orange star below. And so there is no orange star here in the figure, but they mean here, right? And you see where it says insert node or bus. You're going to see that. It says insert node or bus, select node finder, right? So insert node or bus. I don't see node finder. Let's try that. There we go. Then you see node finder right here in the next window. Select that. Okay. And then it says in the node finder window that pops up, make sure that pins all appear in the filter drop down menu, and then press the list button. So make sure this says pins all like that. Then press the list button. Let's go ahead and hit list. There we go. It says with the signals available shown, press the next to include all of them in the VWF file. So we can hit, let's see if I can do this. There it is. Right there, you see the single arrow, the double arrow going to the right, and then you see the single arrow and the double arrow going to the left. Right, I want to add all of these to this selected node, so I'm just going to hit this, and there you go. All of them are brought into the following selected nodes. Okay, after this, what you want to do is press OK on both the node finder window and the insert node or bus window to complete the task of adding signals. And then we are going to see the VWF window change. So let's go ahead and hit OK here, right? And hit OK here. And there we go. Your window should look like this. A, B with an X, the two inputs and the output. Then you should see B0, B0, BX. And it says edit the input signals to produce, this is step 5, edit the input signals to produce all the possible binary input combinations, 0, 0, 0, 1, 1, 0, and 1, 1. Okay? So the way they do that, it says first left click on the signal. This will appear. Okay, so first left click on the signal. Oops. Maybe there. There we go. So you got to click it over here. It says then left click on the overwrite clock tool highlighted above. Okay. In the clock window that pops up, edit the period to be 1000 nanoseconds and press OK. Let me double click again. There we go. Is that correct? That is left click. Left click on the overwrite clock. Oh, I'm sorry, I did the wrong thing. The overwrite clock is this. Where is it? Where is it? Right there. That little symbol right there. Right. This is called the. You see right there. It's highlighted and it pops up. Overwrite clock. It's right next to the count value, and over here is the arbitrary value. So that's the overwrite clock is right between those two. Click on that. Okay. And then we get this clock window. It has the period, the offset, the duty cycle. We want to go ahead and change the period to 1000 nanoseconds. So right now it's at 10 nanoseconds. Let's go ahead and just 1, 0, 0, 0. Okay. Then it says press OK. Nothing else changes. Okay. Just lastly, edit signal B with the same process, but the period should be 500 nanoseconds. Okay. So let's do B overclock. I'm sorry, the clock overwrite clock. And we're going to do this one to 500 nanoseconds. 500. Is that micro or nano? It's micro. Nano. Okay. Let me make sure this one also was in nano. Yep, that's nano. I don't have my glasses, so. Wait a minute. That's 500. That should be 1000. We hit OK. One microsecond. Okay, 500 nanoseconds or 0.5 microseconds. Try that again. Okay, and so our diagram is starting to look now like the one on the handout. Since notice signal X has crosshatches, this represents unknown binary values since a functional simulation has not been completed to determine the actual results. So right here with X, you're going to see all the crosshatch values. Just for future reference regarding input signals, the period of input signals will follow a protocol of 1000 nanoseconds, 500 nanoseconds, 250 nanoseconds, 125 nanoseconds, 62.5 nanoseconds, and so forth for each input. All right, now it says save the VWF file, specify the name as lab1, be exact with the name of this file. So let's go ahead and save this. And we are going to save this as lab1. It says waveform there, but make sure we save it as the same file as before, capital L, little a, little b, 1. And this is going to save to a default of .vwf. Okay. That. And there we go. You can see over there, lab1.vwf. All right, and that concludes this portion of the video, which was on creating a timing diagram. Thank you very much, and I will see you on the next video, which will be configuring Quartus to run a functional simulation.